As in the previous class, we did I mean, the all types of formulas like structural formula. I told you fully displayed formulas. You show every atom, every bond. We did the condensed structural formula that you just move from left to right, and you just start writing whatever appears around the carbon atom, like CH3, CH with the CH3 in brackets. This one is CO, then you have C and NH2 is in brackets, the double bond CHO, C with two Cls and F. So you just start writing everything that appears around it. So, and we learned how to write the skeletal formulas, which is that the carbon atoms, think of them as being represented by dots. So that's 1, 2, 3, 4, 5. So 1, 2, 3, 4, and 5, followed by an oxygen, then another dot. So that's the main chain with one dot coming out of it. So that's one at the top. There's a double bond on the third one. There's an NH2, and so that's how you did that. So what we're going to discuss now is I can try and go through one of the worksheets very quickly. And this one, I think, let me just reload this. So we can, where's the worksheet? Just a second. So skeletal formulas, skeletal structural formulas. So we can try and write all of these different types of formulas on this, and we can try and practice them. So starting with, let's try and do this one. So we can try and write the skeletal formula. I mean, the actual formula for this molecule. That's. I mean, the nodes on this chain are your carbon atoms. So that's basically 1, 2, 3, 4, 5, 6 carbon atoms in a straight line. So that's 1, 2, 3, 4, 5, 6. And you can add in the hydrogens. This one will have 3 hydrogens. This one will have 2 hydrogens. Then you have this one, which is also going to have 2 with this one, and there would be 3 hydrogens with this one. The
Sir?
next, हाँ जी.
सर इसके अंदर हमें क्या बताया नाइट्रोजन भी हो इसके अंदर
नहीं, अगर if there was a functional group or if there was anything apart from a carbon chain, then they would show that. So I mean, if you have an OH, they show that there's an OH. Is that clear?
Yes, sir.
Achha, so as an example over here, we did like I mean, there's a nitrogen here, right? I can draw the skeletal formula for this one. So it's basically 1, 2, 3, 4 carbon atoms, 5. On the 6th side, there's an N. Then there's the 1 dot over here, 1 dot over here. So what I can do is I can quickly draw this. So it's going to look something like this. So those are my. So if I draw this, that's 1. A second. So that's 1, 2, 3, 4, and 5. And then there's going to be an N at the bottom. You're going to show the N. Between these two, there's a double bond. So there's a double bond, and then there's 2 dots over here. So 1 and 2. So that's 1 and 2. So that's how you draw the skeletal formula. That's 1, 2, 3, 4, 5. हाँ जी.
लेफ्ट साइड पे भी डबल बॉन्ड है.
कहाँ पे? हाँ ठीक है, sorry. Plus the functional group H, they have to be shown. So I should write this as NH. The functional group H, I mean functional group, the entire functional group has to be shown. So any H that belongs to the functional group, that's got to be shown. So that's how you write the structure. So coming back to this, it's 1, 2, 3, 4, 5 carbon atoms, and there's one carbon atom coming over here. So that's 1, 2, 3, 4, and 5 carbon atoms. And the second one, there's a carbon atom over here, and you can add in the hydrogens. It's this one will have 3. It's coming to what? How many carbon atoms would this one have? Sorry, hydrogen atoms. क्या होगा? How many hydrogen atoms would this one have?
सर एक.
ठीक है, so there's going to be 1. This one will have 2. This one will have 2. This one needs 3 more. So that's your molecule. I can try and do this one. So that's 1, 2, 3 carbon atoms. And there's a carbon atom over here. So that's 1, 2, 3 carbon atoms, and there's a carbon atom on the second one. Over here, there's an OH attached, and on the second carbon atom, there's a Cl that is also attached. This one will have 3 hydrogens, this one will have 3, and this one will have 2 hydrogens. And let's do this quickly as well.
सर
हाँ
सर, तो इसका मतलब जब कार्बन नहीं हो, कार्बन के अलावा कोई और हो, तो वो लाइक वो मेंशन करेंगे ना, वहां
हाँ,
पे डॉट के बजाय कोई एलिमेंट डालेंगे.
that's going to be mentioned. ठीक है. So this one, 4 carbon atoms, and there's this. So 1, 2, 3, and 4. There's a carbon atom over here, and there's a Cl that's attached on the second from the right. This one will have 3 H's. This one will have 1 H. This one will have 1 H, 3 H's, and this needs 3 H's as well. So that's your formula, and similarly, you can draw the skeletal formula for this. How many carbon atoms? That's 1, 2, and 3 carbon atoms. So that's 1, 2, and 3 carbon atoms. On the third one, there's NH2 attached. So over here, there's NH2 attached. And on the first one over here, there's a double bond O and OH attached. So there's a double bond and OH that is attached. So that is the skeletal formula of this molecule. It's 1, 2, 3 carbon atoms, 1, 2, 3. NH2 on the third one over here, and the first one, there's a carboxylic acid that's attached. Achha, is this clear? This whole thing, is this clear?
Yes, sir.
TK, everyone else, is this clear?
Yes, sir.
Achha, so
Yes, sir.
so now what we're going to do is we're going to try and start naming molecules. Just hold on a second. Achha, so naming organic molecules, and we're going to go into a lot more detail compared to AS. Remember, naming is important in AS because I mean, you might get a direct question on this. That would mean it would just be a 1 or 2 mark question when it comes to naming. Because I mean, it can't be a bigger question than that. It can at best be a 1 or 2 mark question. But everything would depend on that question. Maybe they ask you that there's a molecule that's 2,3-dimethyl-butene, and they would ask you, every question would be based on that molecule. Now, if you don't know what that molecule is, you wouldn't be able to answer any of the questions, any of the reactions, any of the products that are forming. You wouldn't be able to do that. So that's why naming is important. So direct questions are not that important, but indirectly, it's very important. Like, you can't do anything if you don't know what a molecule is. So starting with naming, and I'm going to talk about simple naming, simple straight chain molecules first, simple naming first. Simple straight chain molecules, just one functional group, no complication at the moment. So let's do the basics first, and we'll run through the homologous Cs that we have, the common ones. The first one is alkanes. Hopefully everyone knows what an alkane is. An alkane is a saturated hydrocarbon. So it's a saturated hydrocarbon. That's what an alkane is. Saturated means that all bonds are single bonds. So it means carbon and carbon are making single bonds. That is what is meant by saturated hydrocarbon. Means it's only going to have hydrogen and carbon atoms. The first thing is you're going to learn how to figure out what the prefix is. Like what would the name of the molecule start with? The name of the molecule starts with the number of carbon atoms. So the very first thing is your prefix, which is based on the number of carbon atoms. And you already know some of the counting. It's meth, eth, prop, but. And then there's but and but, then there's pent, hex, and hept, and oct and non, and dec. So the molecule name will be based on the number of carbon atoms that are part of the straight chain that we're talking about. But means 4 carbon atoms, hept means 7 carbon atoms, and so on. Okay, is that part clear?
Yes, sir.
Then the next thing is so alkane. Alkanes are easy. Remember, I'm not going to spend a lot of time on basic stuff. So alkanes are easy. The suffix is going to be in. That's the suffix. So we can do just one example for this one. Suffix means that the molecule name will end with ane. That's what the suffix is going to be. So for example, I'll just do one example, which is I have a molecule and it's an alkane. It's a saturated molecule. The first carbon atom will have 3 hydrogens. This one will have 2 hydrogens, 2 hydrogens, 2 hydrogens, and this one needs 3 more, so 3. Can anyone tell me what the name of what the prefix of this molecule is? 5 carbon atoms. What would it start
Pent.
with? Okay, that's going to be pent. And what would it end with? It would end with ane. So the molecule would just be pentane, right? And I'm assuming everyone knows this, TK. So is this clear? Alkanes.
Yes, sir.
Okay, so we're done with alkanes. We know how to name. We know how to name alkanes. The next one, the second one is going to be alkenes. And they would be kind of the same except with some additional steps. So alkenes are your unsaturated hydrocarbons. So they are your unsaturated hydrocarbons. Unsaturated word means that there is going to be a double bond, a carbon and carbon, double bond in the molecule. That's what an alkene is. They have a general formula which is CnH2n. The previous one also had a general formula which was alkanes had a general formula which was CnH2n plus 2. So remember, general formulas are only applicable to simple molecules. More complicated molecules, the general formulas are not going to work. Same goes for alkenes. So don't rely on general formulas. They're not very good. I mean, they don't work very well. If a molecule has 2 double bonds, it's still an alkene, but the general formula is not going to work. In a cycloalkane, the general formula is not going to work. So there are lots of exceptions. So the general formula most of the time is not working. So it's better not to rely on a general formula. Anyways, the suffix of an alkene is the name of an alkene will end with ene. That's going to be our suffix. So if I have a molecule and I have 5 carbon atoms and there's a double bond, 3 H's with this one will have 2 H's. This one is 1 H, 3 bonds, so that's 1 H. And this one will have 3 H's. So what's the prefix for this one? Starting name, what would it start with?
Pent.
Okay, so this again would be pent. and it would end with "een," right? Now, with functional groups and with a lot of functional groups, there's this additional thing that needed is that you need to tell the position. You need to tell where the double bond is, and you're going to count the double bond from the side that gives the smaller number. From side which gives the smaller number. So, I mean, it's going to be this side. It says this is 1, this is 2. So that means before the double bond, before writing the "een," you're going to tell them that it's at position number 2. So this would mean it's the position of the "een" functional group, which is the double bond. Is this clear? This thing?
Sir?
हाँ जी.
Sir, तो हमेशा like smallest distance हमें choose करना होगा.
But there are rules for that. We'll discuss those rules later on. But right now, we're just trying to keep things simple. Abhi, let's assume that you're going to count from the side that gives the smaller number to the double bond. But I'm going to do the counting rules and expand on this later on. Okay. So, but not right now. So this is pentene. Then there's going to be other scenarios where there might be 2 double bonds. So, for example, if I have a molecule and the molecule has 2 double bonds. So first thing, what's the prefix for this molecule?
But.
Okay, this one is going to be but, and it's an ene, obviously, because it's got a double bond. It's an alkene, but there are 2 double bonds. So for 2 double bonds, you're going to write di. It's a diene. And you're going to give the position of both double bonds. So you're going to count from, I mean, you count from either side, it gives the same number. So in this case, this would be 1, 2, 3, and 4. So one double bond is at position number 1. The other one is at starting at position number 3. So it's going to be 1, 3, diene. So you're going to give the position of both double bonds. So you can have multiple functional groups. You can have more than one. So if there's 2, that's di. If there's 3, then that would be tri. If there are 4, then that's going to be tetra. Is that clear? This one? You clear, Sanoko? Is this clear? Also, is
Sir,
this?
could you
Yes, sir.
please explain it again?
This thing?
Yes, sir.
And the first thing, it's an alkene, right? Sure. I mean, but is 4 carbon atoms. That's the prefix. The end would be ene because it's an alkene. The only thing is that since it's an alkene and there are 2 alkenes, it's 1 double bond and 2 double bonds. So which is why before the ene, you're going to write di.
Okay.
I mean, it's just like carbon dioxide. That means diene means the 2 double bonds, right?
Yes.
And because there are 2 of them, so you would have to mention the position of both of them. So one is at position number 1. The other one is at position number 3, right?
Okay. Okay.
And we can do another one, like I can just do another one where there could be 3 double bonds, like let's do a bigger chain, and let's say there's a double bond here, there's a double bond here, and there's a double bond on this side. So this one, I'm not going to draw the hydrogens. I mean, you can add the hydrogens yourselves. This one would be 1, 2, 3, 4, 5, 6, and I think 7. So that's hept, right? And it's obviously an alkene, so it's ene. But there are 3 enes, which means it's going to be a triene. It's going to be a triene. And you would have to mention the position of each one of them. So this is 1, 2, 3, 4, 5, and 6. So that means it's the double bonds are at position number 1, 3, and 5. So it's 1, 3, 5 triene. Is that clear?
Yes, sir. Thank you.
And also, there's another thing about this that I mean, just a small point about this is how to write the names. So remember this thing, there's just a very tiny point, and that is when you have two numbers next to each other, the number and another number, they're going to have a comma in between. And if you have a number that's next to a letter or an alphabet, then there's going to be a dash between them. So you can, you should follow this, this system. So if you want to write 135, don't write a dash, it's going to be a comma. 135, it's 1, 3, etc. So commas. And when you have a 5 and you have a letter or T coming next to it, there's going to be a dash. So make sure you follow this this thing when you're writing this. They would probably not cut marks for that if you don't follow that, but that's what the convention is. So let's move to the next one. The next one is an alcohol. So alcohols, so alcohols. Alcohols have OH groups. And they have OH groups, and they could have any number of OH groups. That's the main functional group. The general formula, which most of the time is not going to work, is CnH2n plus 1 and OH. The suffix is going to be all. So it's going to end with all. The name is going to end with all. So you've got anes, you've got enes, and you've now got alls. So let's start with a simple molecule. I've got an OH and 2 H's with this one, 2 H's, 2 hydrogens, and this one will have 3 hydrogens. So can anyone, what's the prefix? How many carbon atoms?
But.
So it's going to be but, and the suffix is all. But there's going to be something that's going to be in the middle, and that's going to be your AN. This AN is very important. From now on, you will have this middle thing as well, which you didn't have before. From now on, what will happen is that that's a prefix, that's the number of carbon atoms, that's the functional group, all, and there's going to be an AN. So it could be, this thing could be an AN or it could be an EN. What does this middle part represent? If it's an AN, then that means it's a saturated carbon chain. That means there is no carbon double bond carbon. But what if it could also be an EN? The middle part could be an EN as well. That means it's unsaturated. That means that there is somewhere in the carbon chain, there's a double bond. Carbon and carbon are making a double bond. So remember, this one is butanol. It's, the name of the molecule is butanol, but you have to be careful about this AN from now on. Every molecule that we study from now on will either have an AN that would represent that it's an alkane type thing, like it's all carbon bonds are single bonds, or it could be an EN. That means it's an alkene type thing, which means the carbon chain somewhere has a double bond somewhere. And if it's a double bond, then you would have to mention the position as well. So let's try and do another one where there is a double bond. Is this part clear? This AN and EN thing.
Sir?
हाँ जी.
Sir, ये हमारे O levels में तो नहीं था ना ये EN?
नहीं, अब तो नहीं, EN
Okay.
आ जाता था, but obviously in all of us the naming was very basic. Like you just had to study for up till 4. You just had to study up till but. That's it. So just hold on a second. The board is hanging. 1 second, let me reload. Just 1 second. Okay, it's connected now. I said this one. So slightly more complicated one. Let's go with the same length. I've got a double bond here, and I've got an OH on this side, and let's have multiple OH groups. Let's have another OH group. Let's make things slightly more complicated, and this one will have 2 hydrogens. This one will have 1H, this one will have 1H, and this one will have 2 hydrogens, right? So this one, first thing, what's the prefix? How many carbon atoms?
4.
So it's going to be bute, right? And it's an alcohol, obviously, because there's an OH group, so there's going to be all, right? I said in the middle part, is it going to be AN or EN?
Ian.
Okay, so it's going to be EN because there's a double bond now. So this is butanol, it's a butanol molecule. Now you would have to mention the position of each one of the functional groups. The first thing, let's start with the all. First thing, there are 2 of them. Like there's an OH and then there's another OH. So that's the first thing is it's going to be a diol, right? There's only 1 EN, so there's not going to be diene because there's just 1. Now, the other question would now be, now you would have to number both of them. Like where is the double bond and where is the OH group? I mean, you have to always mention the position of the functional groups. Now, the next question is, which side would you count from? Would you count from the right side or would you count from the left side? Because remember, if you count from the left side, the double bond gets a smaller position. If you count from the right side, then the OH gets a smaller position. So who do you give a smaller position to? Like which side would you count from? Does anyone have any
So
idea?
left side.
So the OH will get bigger numbers, right? If you count from the left side. So the thing is, I said, now I'm going to talk about numbering and counting because we are stuck now because I don't know if I want to give double bond the smaller number, because if you count from the right side, it gets 3. On the left side, it gets 1. But if I give this 1, then that would be 4. So who do I give a smaller number to? And the rules for that. And the rules are, here's I'll just explain the major rule for numbering and counting, and that is the numbering system. Let's call that the numbering system. And the rule for the numbering system is smaller number needs to be given. Smaller number should be given it should be given to the highest precedence group. That would always be given. The smaller number should be given to the highest precedence group. That's the numbering rule. So the question is, what is a precedence group? How do you figure out who's the highest precedence group? What that basically means is that there are certain groups that are more important than others. And you try to, so what that means is that there are certain groups that are more important than others. Like over here, I've got 2 groups. I've got OH and I've got a double bond. So which one is more important? Who do I give a smaller number to? Should I give the smaller number to OH? Should I count from this side or should I count from the other side and give a smaller number to double bond? So that is determined by the precedence order. Some groups are more important. So the point is you pick the highest precedence group. And there's a list, there's a rough list which I can which gives you the importance of these groups. That rough list is that starting with carboxylic acids are the most important group. So if a molecule has carboxylic acids, you're going to count from the side that gives the smaller number to the carboxylic acid. You don't care about the other groups. Whatever number they get, you don't care about them. You just care about giving a smaller number to carboxylic acid. The next one is nitriles. You haven't done nitriles so far, or aldehydes and ketones as well. So we're going to discuss that later. So you had aldehydes, then you have ketones, and after that you'll have alcohols. So alcohols are like not that important. Then amines. If there's nothing there, then you're going to talk about the double bonds. If still there's and lower down, it's going to be your alkyl branches and halogens, etc. Anyways, that's just a rough precedence order, because the complete one we're not interested in the complete one because there are lots of functional groups that we're not going to study.
सर
हाँ जी,
सर आप वो कंपाउंड को फिर से शो कर सकते हैं जो आपने ऊपर ड्रॉ किया था?
मैं शो कर रहा हूँ. अच्छा, but पहले इसमें first thing, according to the precedence order, who's more important, alcohols or double bonds? I mean, it's
alcohols.
Alcohols.
So alcohols are more important. So you're going to count the number, smaller number should be given to the highest precedence group. So you're going to count from the side that gives a smaller number to which one? To OH, which is why. So remember the precedence order. You can't just randomly count from all sides. It's not, and it's not that you're supposed to give smaller numbers to every group. You're going to give the smaller number just to the highest precedence groups. You don't care about the other groups. Like in this case, I don't care what double bond gets. All I care about is OH. I want to give it a smaller number, so I don't care what the double bond gets, which in this case would be 3. So anyways, coming back to this, it's a diol, it's 2 alcohols. So one of them is attached to carbon number 1, the other one is attached at carbon number 2. I mean, one is over here and the other one is at carbon number 2. And where is the EN? Where's the EN? That's at 3. So that's my molecule. It's a butanol molecule, and the positions are also हाँ जी.
Sir, diol क्यों होगा?
There are 2 OH groups, no?
Okay, sir.
So let's do another one. Let's try and so let's say I have this molecule. So first thing, but, right? It's an alcohol, so all, and it's an EN, right? So it's butanol, right? Did I draw the same thing? So it's almost the same thing. So how many OH groups? That's going to be 2 of them, right? So that would make it diol. How many ENs? There's the 2 of them as well. So that's going to be diene as well. Is that clear?
Yes, sir.
And then,
sir? सर ये जो आप कह रहे हैं कि डाइन, ये इसे नंबर से रिप्रेजेंट करते हैं या लेटर से, जो प्रीफिक्स होता है, या डाई या ट्राई, या सिर्फ 2 या 3 लिखेंगे?
नहीं, डाई लिखोगे ना, अगर नंबर तो पोजीशन होता है.
नहीं सर, जैसे ऊपर आपने लाइक 3 लिखा है तो उसे ट्राई लिखना होगा, तो इस तरह से ऐसे कुछ ऐसा
ट्राई लिखोगे ना, ट्राई लिखोगे. 3 is the position. 3 states ke where the carbon is on which carbon is the double bond present. Number jo na, that's the position. Like di or tri, you have to write di or tri, not 3 or 2. 3 or 2 would mean position. Is that clear?
Yes, sir.
So the 2 double bonds, so you're going to write di. The 2 OH groups, that's going to be diol. Position is counting which side, left side or right side?
Right side.
Okay, you're going to give the smaller number to the OH group. So you're going to count from the right side. So it's going to be 1, 2, 3, and 4. So that means the OH are at position number 1 and 2. And the 2 enes are at position number, there's one at 1 and there's another one at 3.
Sir?
हाँ.
सर असल में मैं कंफ्यूज कर गया था जो उसकी लाइक कार्बन डबल बॉन्ड्स की जो मीन पोजीशन है और डाई के अंदर के कितने अमाउंट उसकी कितनी है ना तो
हाँ.
असल में मैं उसमें कंफ्यूज कर गया था
नहीं वही मैं कह रहा हूँ ना वो उसको डिफरेंशिएट करना कि डाई इज for how many OH groups do you have? And the number is for the position of those OH groups. ठीक है? So is this clear, Osma? Tanya, is this clear? Sidra, is this clear? Amna?
Yes, sir.
So let's continue with this. We'll probably finish naming in the next class, and then we'll start with isomers and reactions. I mean, this is basic naming. We haven't talked about branches yet, and we haven't done a few of the functional groups. But the main system is exactly the same. The only suffix would change. Like if I do another functional group, the suffix would change. For carboxylic acid, it's going to become oic acid. So this end part would change. The main system of naming would remain exactly the same, except for the suffix changing, right? So let's continue next time.
सर
हाँ जी.
सर वो अपलोड कर देंगे वो पिछला लिंक जो था थर्सडे वाली क्लास का
हाँ वो मैं देखता हूँ मतलब वो अपलोड किया हुआ ठीक है. ओके.
ओके सर थैंक यू सर
टेक केयर.
सर
जी जी.
आप पिछली सारी लास्ट क्लासेस आप YouTube पे अपलोड करते हैं?
एक सेकंड. नहीं क्वेश्चन कौन पूछ रहा है?
सर महद.
अच्छा महद बोल. नहीं उसके ऊपर है लेकिन है वैसे उस पे. मुझे बता दो कि I'll share a वेबसाइट पे भी है megalecture.com पे भी है. It's just that they're unorganized a bit. तो मुझे send me a topic ठीक है which topic you would want. So I'll send you the organized one. Probably किसी Excel sheet
Hey.
पे हो.
Sir, do you not like upload them at Drive anymore?
The Google Drive?
Yes.
It depends. Well, it gets uploaded on the Google Drive as well. But the Google Drive folder is also very unorganized. Because all the classes are kind of jumbled up. You want the video lectures?
Yes.
ठीक है. I'll share a link with you. ठीक है. I'll share the link with everyone. It's going to be an Excel sheet. And in that, I mean, I organize things on that Excel sheet. But they are kind of organized. So I'll share the Excel sheet. So in that one, topic wise, all the links of the YouTube lectures would be all there. So you don't have to sort of Google or search. You can just click on the link on the Excel sheet. It's a Google sheet. So I'll share that with you. ठीक है?
सर
हाँ जी.
सर वो आपने स्टेट्स ऑफ मैटर टॉपिक किया आपने
बल्कि एक सेकेंड let me show you. हमने पहले किया था. We'll do that again. We still have 3 months. ठीक है? 1 second. Let me just share you